Okay, in this session we're going to look at compound increase or decrease questions using the power formula to calculate them. So that's what hopefully you will have revised before having a go at these questions. And the way that that formula works is that if you're given an original amount, and let's say that original is going to be increased by 5% every year, for 10 years. The original is what we consider to be 100%. So if that is having an annual increase of 5%, that means that every year you're going to end up with the 100% plus another 5%. So that's your increase factor, and over that period of time. So the way that you then calculate how much you get at the end of that is you would multiply the original by the increase factor, so in this case 105%, to the power of however many years there are. So increase factor to the power of 10 times the original. That will then give you what you've got after 10 years. So if they want to know what the increase is, you would take the original off that. And it's the same thing if it was a decrease. So let's say we're decreasing by 5% for 10 years. The original we'd consider to be the 100%. So a decrease of 5% means what you're working with is 95% of the original. You're taking, because it's a decrease, you're taking the 5% off. So this time what you'd be doing on your calculator is the original value times 95% to the power of 10. And again, that would tell you what it's worth after 10 years. If they want to know how much it's lost after 10 years, you would take that away from what the original value was. So it's these pieces of maths that we're going to be working with, which makes it a much quicker method than maybe the method you were originally taught this back in Key Stage 3, where you would work it out year by year. You'd work out what the increase is, add it on, then work it out again for the second year, add it on, and so on. But what's happened with the WJEC now is they tend to go for longer periods of time to make it more realistic, but it means that that method is just too long-winded to work with. So it's this method that we'll be looking at using. Even though some of these questions are actually older style WJEC questions where you could do it working year by year. Okay, question 1. Let's just zoom in a little bit. So Elved invests £3,500 for 2 years at 1.5% per annum compound interest. So the original is 3,500. Which we're going to times by the increase. Well, the increase, if it's 1.5%, we're going to have 100% plus 1.5%, which will be 101.5%, and over 2 years. So to the power of 2. Now, you can type that in your calculator exactly as you see it, and the way that I would teach it, certainly that's what I would get you to do, is to use the percentage button on your calculator, which is shift open bracket. So the way that I would get that done would be to type into your calculator exactly as you see it there. 3,500 times 1.5 sorry, what am I on about? 3,500 times 101.5%, and then because it's squared, we can just use the squared button there. So the original times the increase, 101.5%, to the power of the number of years equals 3605. And what we're asked for here is the value of his investment at the end of the 2 years. So that's how much is in his account at the end of the 2 years, which will be 3605. And then to the nearest penny is either going to be 78 or 79. You look at the next digit over, it's bigger than 5, so that's going to become £3,605.79. And that's it for 4 marks. Now you may have been taught, rather than use the percentage button, to turn that into a decimal first. Well, 100% is 1, so that's going to be 1.015. So if you did it that way, you'd end up with exactly the same answer. What the percentage button does is turn that into that. So if that's the way you work, just to show you, 3,500 1.015 squared is the same thing. Question 2. Gracie invests £8,240 for 2 years at 3% compound interest. Find the compound interest earned in the 2 years. Now that is saying, I don't want to know how much is in the bank account, like the first one. I want to know what it's earned, what it's gained over those 2 years. So that's the only slight difference here. So the original is 8240. This time it's going to be 100% plus the 3%, 103%, and for 2 years to the power of 2. I'm picking up the light on this. Here we go. So 8240 times 103% to the power of 2. So that one's £8,741 to the nearest penny, 82. So 874182. That's what's in the bank account. So the interest earned is how much is in the account less what's originally put in. So 874182 less the original sum. So 8 less 8240, £501.82. I haven't mentioned how the mark scheme work for this, so just bear with me a sec. So with that, question 1, there's a mark for correctly recognizing the increase as a percentage. So you get 1 mark for the 101.5%. Then you get a method mark for your formula, your increase. 1 mark for getting that and not rounding it. And then the final mark for actually getting it to the nearest, correct to the nearest penny. So the same with the second one. You'd have 1 mark for the 103%, or 1.03 if you're going to work as a decimal. Method mark then for correctly setting out the maths. 1 mark for an answer which you haven't correctly rounded, and the final mark for that correct rounding. So with that one, if you didn't want to use the percent button, you would have done 8240 times 1.03 squared. That's more work, if you ask me. Question 3 is the same as question 1, isn't it? No, it's not. Elfed and O'Leary. Okay, well, there you go. There's a slight difference. So this time, the original amount is 3,700. This time, it's 3 years at 2%. And they want the value of her investment, so that means they want how much is in the bank account. So the original, 3,700, times the increase is going to be 102%, and this time for 3 years, so to the power of 3. $3,700 times 102%, and because it's to the power of 3, we can't use the squared button. We've got to use the general power button next to it. My pen is pointing, and put a 3 in there. To the nearest penny, so it's going to be 3926 point, and then it's either 46 or 47. The next digit is a 9, so it's closer to 47. So that's it, all in one line, 4 marks. 1 mark for the 102%, or 1.02. 1 mark for the line of maths. 1 mark for an answer that's unrounded, and 1 mark if you correctly round your answer. So again, if you want to go decimal version there, the alternative would be 3,700 to turn 102% into a decimal, be 1.02 to the power of 3. Question 4. A company was set up with 500 workers. At the end of each of 3 years, the company employed more workers. The number of additional workers employed each year was equal to 2/5 of the number of workers that there were at the start of the year. How many people worked in the company in the 4th year? So, first year 500, and then after that there'll be an additional 3 years increasing on that value. So what we've got here is an increase of 2/5. Well, 2/5 is the same as 0.4 or 40%. So what we're doing is, if the original amount is the 100%, every year what we've got on top of that is another 40%. 2/5 is a percentage. You shouldn't need to use a calculator for this, but just to show you, 2/5 to turn it into a percentage times by 100 is 40%. So the increase, 2/5 is 40%. So we're working with a factor of 140%. So what we've got is 500 is the original times our scale factor, which is 140%, and then this increase, how many people worked for the company in the 4th year, is what they get at the end of 3 years. So it's the first year increase, second year increase, third year increase. That's who's working the 4th year. So that's going to be to the power of 3. So 500 times 140% to the power of 3, 1,372 workers. And it's not asking for how many more, it's asking for how many, so we don't have to take away the original. So that was a bit trickier because it's giving you, rather than as a percentage, it's giving you the compound as a fraction, and you need to work it out from there. So 2/5 as a percentage is 40%. The original team was your 100%, so it's being increased by 100 plus 40 is 140. Or if you go down the decimal route, 500 1.4 or 1.40 to the power of 3 will get you the same place. Part B, calculate the percentage increase in the number of workers from the first year to the fourth year. So this isn't compound, but it is something that you need to be able to do, is to work with percentage change, whether it's percentage increase or decrease. So what you need to know is that the percentage change, so that's up or down, works both ways, is the value of the change over the original amount so that would give it as a fraction, and then times 100 to turn it into a percentage. So if it's increase or decrease, what is the change, divided by what was the starting point, times 100. So in this case we've gone from 500 to 1372, so the amount of change is 1372 less the original, 872, over the original, well the original was 500 workers, times 100. And you can type that into your calculator exactly as you see it. So fraction button, 872 on top, 500 on the bottom, times 100. So, and that's the great thing about these calculators, is you can type it in exactly as you write it. So 174.4% increase. Okay, so the marks for that question. So the first mark, well, we know how this one works, is for working out your scale factor. There's a method mark for the line of maths. And in this case, because that's more complicated, there's 2 marks for getting to the 140%, and there's 2 marks, one for the method and one for the answer of 1,372. And then for this question, there's 1 mark for the 872, just working out what the actual change is, 1 mark for the correct method, and 1 mark for 174.4, or 174 would have got you that mark as well. Question 5. Each year Enrico's car loses 12%, so now we're into depreciation. Loses 12% of its value at the start of that year. The car was worth £17,000 when it's new, so that's your original. What was its value after 3 years? Give your answer correct to the nearest £100. So this time we're not increasing by 12%, so it's not going to be 112%, it's going to be less 12%. So let's just write that down because it's a bit different. So it'll be 100% less 12%, which is 88%. So this is what's going into my my line of maths. So the original, 17,000 times 88% to the power of 3. So 17,000 times 88% to the power of 3. Type that in again because the light was shining, wasn't it? So 17,000 times 88% to the power of 3. So that is the complete answer. So if we just write that down, 11585.024, then that will get us a mark. But what we haven't done is then written it down to the nearest 100. So the nearest 100, units, tens, hundreds, so it's either going to be 11,500 or 11,600. Because of the £85, it's nearer to 11,600. So that's where your final mark comes in. So mark scheme for that. 1 mark for the 88%. Your method mark for the correct line of maths. An answer mark for an unrounded answer. Final answer mark for the answer correctly rounded to the nearest £100. If you wanted to do that as a decimal, then it will be 17,000 times an 88% would be 0.88 to the power of 3. Either of those, absolutely fine. Question 6. Rowena owns a car that David is planning to buy in 3 years' time. Rowena's car is currently worth £3,500 and she estimates that her car will repeatedly depreciate by 24%. So depreciate, it's losing money. David has already saved up £100 and he wants to set up a savings account to save a fixed amount of money each month to buy Rowena's car in 3 years' time. What would be the minimum amount of money to the nearest pound that David should pay into his savings account each month? So this is a much more unstructured question and it's worth more marks. So in order to know how much he needs to save, we need to know what he's aiming to save. We need to know what the value of that car is going to be in 3 years' time. So because it's depreciating, it's dropping by 24%, so the factor, the depreciation factor, will be the original amount, 100%, and we're dropping by 24%. So we're going to be working with a percentage value of 76% over 3 years. So our line of maths is going to be 3,500 times 76% to the power of 3. %, or 0.76 to the power of 3. So let's say that is £1,536.42. Now this is an estimate, so it doesn't need to be as accurate as to the nearest penny. So let's say, let's round that to 1540 even. So we're saying that David needs to have that much money in his bank account at the end of 3 years. So he's going to be saving monthly. So 3 years, 3 12's 36 months. He's already saved £100, so he needs to save another, that less 100. So he needs to save that much in that many months. So his monthly savings are going to be that divided by 36. £40 a month. Okay, so there's more work to do there, which is why it's worth 7 marks. So how are those marks allocated? Well, there are 3 marks for this piece of work. So you're going to have the usual mark for the 76%, mark for that. Whether you decide to stick with 15, 36, 42 or round it off, it doesn't matter. You got your 3 marks for that. There's a mark then for taking off the £100. There's a mark for dividing your value by 36. There's a mark for getting your answer, and there's a mark for making sure your answer rounds to the nearest penny or the nearest pound or the nearest £10. You're not writing down 10 decimal places. So those are those 7 marks. Part B. Do you think that this amount saved each month will guarantee that David will have enough money to buy Rowena's car? So they're checking your understanding here that, where's it going? Things could change. Rowena is estimating her car will depreciate by that much. So it may depreciate by less, so it could end up with it being worth more than that value, in which case he can't get the car. So you can actually answer this question correctly by saying yes or no, depending on what argument you want to make. So I'll give you both arguments. Do you think that he will be guaranteed? No, because Rowena estimates the car will depreciate by 24%. It might fall by less and still be worth more. It could depreciate by more than 25%, 24%, so it could be worth less. So you could argue yes, because David, because he's saving in a bank, will earn interest on that. So yes, because David will earn interest on his savings, so we'll have more than this amount in his account. So there are different arguments that you can make. What's important is that you're not just saying yes or no, you've got a because after it and a reasonable conclusion or argument why it's yes or no. So that's a nice numeracy style question there.